Example 8. A 400 Newton southwest wind pushes a sailboat 2,000 meters due west. How much work is done by the wind? Hint west and southwest make a 45-degree angle. So, just picture to help you guys out. Right? What do we know?
It has 400 newtons.
Force is
Okay.
400.
So, the force from the wind is 400 newtons, right?
Displacement.
So, F is 400.
D equals 2, 0, 0, 0.
Okay, good. D equals 2,000.
Oh, you wrote that twice.
What else?
Angle is 45.
Angle is 45.
Theta equals 4.
You're trying to be a robot now?
He wants to be the G.
Nanagon, the robot. Okay. So, what do I do now?
Plug it in.
We add nothing, Michael.
Plug it in.
Plug in the number.
Plug them in and multiply, right?
Plug
Yeah.
in
Plug it in.
I did it on an iPhone calculator.
So, 400 times 2,000 cosine 45. Alex, I'm striking my class.
Alex, that's second class.
5, 6, 5, 6, 8, 5,
6,
4, 4,
8,
2, 4,
5.
Okay. So 565,685.42 joules. Okay. Does that make sense? Guys.
I don't get your
Yup.
Okay. Any questions?
How do you change the input again? Because I
We can be
think
done.
it's
What?
supposed to be in degrees. Right?
Yeah, hit mode and go down to degrees. Okay. So make sure in degrees.
Oh, you got it?
All right, guys. Example 9. Example 9. So I do the picture over here. Okay. So the child is climbing up the 2-meter long slide. The child's 35 kilograms. The force of gravity is what they're working against. So their force is equal to the force of gravity. So to find the force of gravity, do mass times gravity, right? So force equals 35 times 9.8. What does that equal?
4. 4. 1. Wait, that's not right. Never mind.
Yes, it is.
Wait,
Oh,
it's
no,
45.
it's 45, so it's
45.
4,
It's 45. 4.
45.
It's not 35. It's 41. No,
45 newtons?
No.
No, take the
No,
number
force
is
is
45, not 35.
Read the
Oh.
equation.
My fault.
You got it.
Oh.
It was a 35 kilogram kid with the wagon.
Serious.
All right.
And then
So-
it's 441.
441.
4.
Okay.
Newton.
Newtons. Good, because forces are always in newtons. Now, okay. One struggle I noticed a lot of you guys having was we were using the wrong theta. Right? We want the angle between the force and the displacement. Right? A lot of us were using 35. Is that the angle between the force and the displacement? No. If the force was horizontal, then that would work. But the force here is not horizontal, it is vertical. So we need to find this other angle. So you do 90 minus 35 and you get 55. So then theta equals 55.
I think theta is like more oval.
All right.
I'm pretty sure.
What's the displacement?
2.
2. So how do we find the work done?
You plug in the numbers you know and you multiply.
Theta.
Okay. Thank you for being literal, Skylar. So force equals 441 times 2 times cosine 55.
Yep.
441 times 2 times cosine 55. What do we get?
5.9.
Okay. Did I call 506?
No.
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 No?
No.
Be
All right.
Accurate.
Well, it's my class. I'm calling 506.
I don't.
Well, I'm going to do that on a
This is
test.
I would be okay with that.
You're so into you tell
All right.
us
democracy.
Why don't
It's
you
not.
round it up to 5?
you tell us to go 2
Yeah.
places, then you
Yeah.
tell us to go 1 and
Why don't
round,
you
and
round us
then
to
you tell
500?
oh am I just
So I just always go 2 places.
Okay, sweet. Keep doing it. All right. I like whole numbers. I'm sorry.
You like cold numbers?
Whole numbers.
Why? What's so cool about cold numbers?
Whole numbers.
Why are they like really
Wait, you
cold?
can put it on your
Okay, there you go.
roof.
All right.
Are
So-
they cold like good?
When the child gets up here, that's why I like them because they're cooler, right?
Oh, they keep your
Because they're
cold?
icy because they're
You
so
get, like,
cold.
you put them in your cups of
Using all the lingo that I hip to. All right. So there's the child up there, right?
What?
The child now jumps down the other side of the slide, right? Jumps down that way. Okay. So how much work will be done by gravity. Now, who did trigonometry to find this other side?
I did.
I wasn't sure how to do it.
Don't know how to use trigonometry yet?
Soka.
That is trigonometry.
Okay, Sokotoa?
Yes.
So-
Yeah,
so-
we're
You guys haven't learned it yet? That's okay.
What do
So-
you-
Who used trigonometry?
I
Soka
did.
style.
Okay, you don't have to.
Really?
Because when the child climbed the slide, how much work did they do?
4.
No, I didn't know how tall the slide is.
506 joules, right?
505.
Right. What did they work against?
Gravity.
So the force they applied was equal to gravity, right?
Yeah.
When they jumped down the slide, what force is going to pull them down, Eric?
Gravity.
Okay,
Gravity.
gravity, right? Gravity will pull them down. What distance will gravity pull them down?
1. 2.
1.
That
Okay.
one.
This same distance
It's always
that they just climbed up, right?
It's 1.
It's not always half, it's another 30 degree
Alright.
triangle.
Alright.
Okay,
Played.
so,
Played.
guys, thank you.
Non-stay.
When they climbed up, right, this cosine 55, that was to find the part of the 2 meters that was in the same direction as the force, right? So if you're good at trigonometry, you know that cosine 55 is really this side right here, right? Because if I draw this triangle, right, cosine 55 is here. That's my distance in the y direction. That's my distance up, isn't it? Okay? So when they jump down, they're going the same distance down as they just went up, aren't they? The same forces being acted on them, right? Or forces that are equal magnitude, right?
Yep.
So how much work is done?
More.
The same amounts. Okay? The force has the same magnitude, goes over the same distance, so the work done is the same. It is not negative because the force of gravity is down and so is their displacement. Because when they jump down, the displacement and force are in the same direction. So gravity is doing the work, right? When they jump down, displacement's this way, right? Force is that way. They're in the same direction. All right. Any other questions? Any other questions about that? Okay. C. Okay. For C. How tall is the slide? We know how much work is done, right?
Yeah.
Work is 506.
Yeah.
Why can't you just find and do something?
Because you can't.
You can, but not all of us know Sokotoa. And I want you to do physics, not geometry.
It's actually free algebra.
So work equals 506, right?
Why did I never learn this?
What's the force? Guys, what's the force? What force pulls the kid down when they jump off the edge? Gravity. So
Tension.
mass times gravity, which is 45 times 9.8, which is 441, right?
Why did you make that
Guys, we're not talking about Sokotoa right now. Okay? So the force is 441, right? Okay? So then I'll do it up here so you guys can see. We know work equals force times distance. There's no angle because the force and the distance are in the or displacement in the same direction. So 506 equals 441 d. How do I solve for d? Divide 441, 441. 506 divided 441 is 1.15. So do not worry. Okay? Do not worry. That child will be okay jumping down 1.1 meters. Okay?
I won't.
It's like this tall. All right, 1 meter tall.
That's a very short
How
slide.
big is the
That's
child?
like an 8-year-old.
It's a kid's slide.
It's like a 3-year-old.
The kid slide in my basement. My daughter does this every day.
He jumps
Climbs up one side, jumps down the other side.
and she's fine.
Yeah, and she's fine.
Why
Okay.
does she do backward slide?
Last one. Example 10 says, how much work does a 1,000 Newton centripetal force do on a car as it travels 50 meters around a curved section of highway? So, here's the curved section of highway. That arc length is 50 meters. So from here to here is 50 meters. Does that make sense?
Yeah.
Okay. Now, if here's the car, here's the center of the circle, which way does the centripetal force point? Which way does the centripetal force point? Towards the center.
Doesn't really make any sense.
Okay.
Which way does the centripetal?
Force point. It doesn't. It's kind of redundant because centripetal means center seeking.
Exactly.
Okay. Yes, Nan.
Okay, for the other question, if we did that on a test and we used Sokotoka, that's wrong, right?
No, it's fine. You can use Sokotoka.
Well, then I got a different answer.
What'd you get?
1.6.
1.6.
1.6. 1.6.
I don't know what I did wrong.
Are you gonna agree?
Did you use 55 or did you use 35? 35?
Yeah.
So you did
Cos.
sine? Should be sine.
Why would it be fine?
Because this is opposite of 35.
I'm still over having that.
Alright.
Real nice. No, I got 1.6.
What is Sokotoa?
So 2 times the sine of 35.
Isn't that like a volcano?
1.1. Okay. You'll learn about next unit.
We're like in 8th grade
Yeah.
math.
Alright guys.
Isn't it like a
Back to
volcano?
this. So
That's how you find all the sides.
guys, thank you. From last units, centripetal force. What's the relationship between centripetal force and the direction of travel? They're perpendicular. Fong, Rex, Omar, pay attention.
Oh.
Hey.
Right? It's Newton's, right?
What?
Centripetal force is Newton's, right?
Centripetal force is Newton's.
I have a question.
So, centripetal force and the direction of travel are perpendicular, right? So what's the angle between this force and the displacement the whole way around? What is it? 90. So in this case, even though the car is moving, theta is 90 the whole way. Right? What's force? 1,000. Okay. What's displacement? 50. Okay. So to find our work done, work equals force times displacement times cosine theta, right? What's force? 1,000. What's displacement? Not degrees, meters. 50 meters, right? Times the cosine of 90. Okay?
That's 0.
What's
What?
0? Cosine 90 is 0. So this whole thing is 0.
Why does it do no work?
So the centripetal force does no work on the car.
Oh, the centripetal force.
Okay.
The wheels.
The centripetal force does no work on the car. So you're probably saying how? We have force and distance. How is it doing no work? Okay. Well, think about this. When we first introduced you to force, we said force and displacement must be parallel in the same direction, right? If I have two lines that make a right angle, so force and displacement, how much of the force is in the same direction as the displacement? None. How much of the displacement is in the same direction as the force?
All of it.
None. Okay? If you're perpendicular, then there's no parts that are parallel. There's no component that's parallel. That's why the cosine of theta was 0. Cosine 90 was 0. Does that make sense, guys?
Yeah.
So this is something you can know. If the displacement and the force are ever perpendicular, how much work is done? 0. So, if force is perpendicular to displacement, no work is done.
So if the angle is like 89 degrees or 91 degrees, then it would work.
There'll be a little bit of work. Okay. So as you walk around with your backpacks on your back, and you carry them through the hallway. Just let's say you walk from my room down to Miss Corrigan's room. Did you do any work on your backpack?
You make 10 revolutions.
No.
That means you go around.
Guys, we're not doing that right now. Okay?
All you're doing is lifting.
All you're doing is holding. Once it's on your back, you're just holding it. You're walking perpendicular to the force you're applying. So no work is done.
It feels like it is.
Well, it's because you got to support that weight.
Yeah.
But you're not doing any work on it.
No, our
Now if you do some deep knee bends with that on there, now you're doing some work on this. Deep knee bends. Okay. Squats. All right. Any questions about example 8, 9, or 10? Any questions about example 8, 9, or 10?
Put my arm on another
Anybody?
Put my arm on another
I can't.
None?